Okay, now we're going to do some exam type questions where we have to, with exponents. And in the first question, we're going to do something where we have to factor, and then you get canceling happening, and then you can simplify it. Okay, let's look at this. 3 to the m minus 3 to the m plus 1. Well, you can go both ways here. If when you multiply two things, you add their exponents. If you have a base put to a sum, then you can write it as a product like this. So 3 to the m plus 1 is really 3 to the m times 3 to the 1, or times 3. So that's a useful thing because you see this 3 to the m, that's a factor, and it's the same in both. It's common. In the bottom, you can see this 3 to the m times 3 to the m. It's common too. Well, let's look at the top now. If it's a common factor, we can write it down once, 3 to the m, then we can put a bracket, and then we put a 1 here. See, 3 to the m times 1 is 3 to the m. 3 to the m times minus 3 gives us this minus 3 to the m times 3. So that works. Now look at this 3 to the m in both of these. So you can write down the 3 to the m once, put a bracket, put a 4. 3 to the m times minus 1 is minus 3 to the m. So it works. 3 to the m is a factor of both of these things. It comes out, and now we have something divided by itself just equals 1. 1 minus 3 is negative 2. 4 minus 1 is 3, so that's negative 2 over 3. Let's look at this next question. So a lot of the questions are factoring type problems. Here's an example. It's an exam question. The first thing, if you see a dot like this, it means that they're multiplying these things together. If they're next to each other, it means they're multiplied together. I put a times thing here to make it a little bit easier, but the key thing is to get the bases into powers of primes. Put them into prime numbers, like 15, make it 3 times 5. 6, make it 2 times 3. 9, make it 3 squared. There's a power of a prime number. And 10, make it 2 times 5. If you do that, you're a long ways on the road to getting the answer. The next question is, each one of these exponents is the bases are put to that power. So this is 3 to the n minus 1, 5 to the n minus 1, 2 to the n plus 2, 3 to the n plus 2, 3 to the 2, put to the n plus 1 power. This 2 has to get multiplied by the n and the 1. That's why it turns into 2n plus 2. There's 2 squared and 5 squared. Now it's just a matter of, let's look at the same base. We write down the base 3. We add all of the exponents on top, and we subtract the 2n and the 2 that's on the bottom. Well, there's your 2n minus 1 plus 2 minus 2n minus 2. There's the 3's dealt with. N minus 1 minus 2. You're subtracting because you're dividing here, see? And then n plus 2, and you subtract 2. Well, that's going to be your answer. You just got to work it out. 2n minus 2n, the n's are gone. 2 minus 2, that's gone. So you just have a minus 1 there. Here you've got n minus 3, and 2 minus 2 is gone, just 2 to the n. Well, there's a 5 to the n, and there's a 2 to the n. You can put them next to each other, 2 to the n, 5 to the n. 3 to the minus 1, the 3 would go to the bottom. 5 to the minus 3, that's times 5 to the minus 3. That goes to the bottom, becomes 5 cubed. 5 cubed is 125 times 3 is 375. And you could write this 2 times 5 with a bracket around it to the nth power. 2 times 5 is 10. So there it looks kind of neat as 10 to the n over 375. We've got a whole bunch of exam questions to try, 11 from about 5 or 6 different years. They come up every time in grade 11 exams, so it's really good to learn how to do them. They come with full memos, so you can check to make sure you've done it right, and hopefully you'll be able to do it. It is a bit challenging. It's not the easiest stuff. Some people find it challenging. You just got to practice it, and you have to know all your laws of exponents. That's what makes it a little bit challenging.